All right, here we're looking at section 10.4, and these are our two learning targets for today. First, we're going to use inscribed angles, and then second, we're going to look at some inscribed polygons. And remember, just a polygon is a shape that has many sides. So we're going to look at some special polygons that we can inscribe in a circle. So the first thing we want to look at is what is an inscribed angle? So an inscribed angle has the vertex on the circle, right? And we talked in previous sections about central angles where the vertex was in the middle, is on the center, and now our inscribed angles are on the actual circle itself. Okay, so we know that both of the rays of my angle will intercept and create an arc, right? So that's kind of the same thing that we've been looking at, except just the measurements are going to be a little different. So when we were looking at central angles, we saw that the angle measurement was the same as the arc measurement. Well, here, since we have inscribed angles, I know that my angle is going to be half the size of my arc. That's what this little part tells me, that the measure of my angle is half of the intercepted arc. So let's look at an example. So here we're asked to find the measure of angle T. So here's angle T right in here, and then we're going to be looking for the measure of arc QR. So the first thing I see, that angle T has an intercepted arc that is 48 degrees. So I know that the angle is half of the intercepted arc. So since the arc is 48 degrees, the angle would be half of that, which is 24 degrees. So now let's look at B, finding the measure of arc QR right here. Okay, so first we have to find a couple of other things, right? So first I have to find arc TQ, right? Because I know this one, because this angle is 50, and I know that the arc is twice the size of the angle, or the angle is half the size of the arc. So if I know this angle is 50 degrees, I know TQ is 100 degrees. So then I can also know, I also see that TR is a diameter, right? Because it goes through the center of my circle. So I know that this entire measurement from T through Q to R would be 180 degrees. So if this is 100 degrees, then I know the part that's left is 80 degrees. So when we're dealing with these kinds of circles and these measurements, we always want to draw out what we have so we can find the information that we're actually looking for. So now let's look at this next example. So I'm asked to find the measure of RS, right? Arc RS, and the measure of angle STR, this angle right up here. So then we have to figure out kind of what we notice about STR and RUS, right? What do we see about those two angles? So the first thing I want to do is I want to find the measure of my arc, SR, or RS, right? And I see that it has an angle that cuts it, and that angle vertex is at U, and I see that that angle measurement is 31 degrees. So I know, based on my inscribed angle theorem, that the arc is twice the size of the angle. So I can just multiply that by 2 and get 62 degrees. So that gives me the measure of arc SR. So now I can look for this angle STR. Well, since I found this arc was 62 degrees, I know that the angle is half of it, which gives me 31 degrees. So I know that these two angles are going to be the same. Okay, so now let's look at why we know that. So this is called the inscribed angles of a circle theorem. Right? So if two inscribed angles intercept the same arc, then the angles are congruent. So here you'll see that I have angle ADB and angle ACB. And I see that they're different angles because they land on different parts of my circle, but they are congruent because they have the same intercepted arc. And so on this last example, we actually proved that and kind of looked at the measurements of where this theorem comes from. Okay, so now let's look and see another example of this. So given that angle E equals 75 degrees, let's find angle F. Well, the first thing I noticed is that E is made up of GEH, right? So this is my intercepted arc. And for angle F, I see I also have the same intercepted arc. So since the arcs are the same, I know that the angles are going to be the same. So angle F is also 75 degrees. So now I want you to try these two and see what you can come up with. So now here's our next core concept, right? Our second learning target for today was dealing with inscribed polygons. And remember, a polygon is just a shape with many sides. So a polygon is inscribed when all the vertices are on the circle. They can't be outside the circle or inside the circle. They have to be on the circle. Okay, so here you'll see this blue pentagon is inscribed because all of my vertices are on the circle. And that circle that contains the polygon is called the circumscribed circle. It's around it, is how I remember it. So here's two different theorems we're going to be looking with this. First one is with a right triangle. So if a right triangle is inscribed in my circle, then the hypotenuse is the diameter of the circle, right? And this would kind of make sense because if I have a right angle, I know that it's 90 degrees, and so its intercepted arc would be 180 degrees, so I know that this would have to be a diameter. Okay, so that's kind of our biggest thing with this right triangle theorem, is knowing that if this is a diameter, then it's a right angle. If it's not a diameter, if we don't have a diameter, then I'm not looking at a right triangle. Okay, so our second theorem here on this page is the inscribed quadrilateral theorem. So a quadrilateral can be inscribed in a circle, right, where all of the vertices are on my circle, if and only if its opposite angles are supplementary. And remember that supplementary means 180 degrees. So I know that the opposite angles, right, so here in this case would be F and D. If I add them, they can get 180. And if I add E and G and 180, then I know that my quadrilateral is inscribed. So let's look at some examples here. So first I have to find the value of this 2x. Well, first thing I notice is that AB is a diameter of the circle because it does go through the center. So I am dealing with a right triangle. Okay, so angle C would be my right angle, which is 90 degrees. So then I can just set up 2x equals 90, so x would be 45. Okay, and I know that because I'm dealing with the diameter of this circle. So now let's look at B. B, here I see I have a quadrilateral, and I know that it's inscribed in my circle. And when I'm dealing with quadrilaterals, I know that when they're inscribed that opposite angles are supplementary. So opposite angles equal 180. So I can set that up as a kind of a little equation. So I know D plus F equals 180. So I substitute what I know, and I can find what Z is, was 100. Then I set up the other two opposite sides equal to 180, substitute the piece that I know, and solve for Y here. So Z is 100 and Y is 60. And I can just look up here and say, well, 100 plus 80 is 180, and 120 plus 60 is 180. So that's how that works out. Okay, so now we're looking at kind of a real-world example. So my camera has a 90-degree field of vision, and you want to photograph the front of a statue. You stand at a location in which the front of the statue is all that appears in your camera's field of vision, as shown. So here's me and my camera with 90 degrees, and here is the statue that I'm looking at. You want to change your location. Where else can you stand so that the front of your statue is all that appears in your camera's field of vision? So what we want to do is we kind of want to turn this into a circle, so because I can stand in many different places where this would still be my intercepted arc. Okay, so let's go ahead and look at what we've done here. So I know that because I'm dealing with a right triangle, this hypotenuse is the diameter of that circle. So using that information, I can just kind of draw the rest of my circle, just like that. So then I can have several other places. Anywhere that I follow on this circle, I will still get this 90 degrees, and I will still end up with only the statue being in my range of motion. Okay, so any point, once I figure out that this has to be the diameter of the circle and I draw the rest of my circle, I know I can stand anywhere on that and still get the statue in my camera lens. So now here are a few that I want you to try. These kind of follow with what we've been doing the last couple of examples, especially when we have multiple variables in my quadrilaterals. See how you can deal with those kinds of things. So let's look back at our learning targets. The first one was to use inscribed angles. The biggest thing to remember when we're dealing with an inscribed angle is that the vertex of the angle is on the circle, and that the measure of the angle is half of its intercepted arc, right? So then we were using some inscribed polygons. And the big polygon that we looked at was quadrilaterals. And I know that when we're dealing with an inscribed quadrilateral, the opposite angles are supplementary, so they add to 180. That will help us to find some of the angle measurements and some missing variables. Now that you've tried this and looked through these examples, now I want you to try your homework for 10.4.